This is SpaceTime, Series 29, Episode 26, for broadcast on the 2nd of March 2026. Coming up on SpaceTime, NASA's return to the lunar surface delayed until the Artemis 4 mission in 2028, a successful hypersonic test flight for an Australian scramjet, and the hidden chemistry at the heart of the Milky Way galaxy. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
In a major announcement, NASA has been forced to delay man's return to the lunar surface until at least 2028 and the Artemis 4 mission. The move will now see next year's Artemis 3 flight to one of testing systems and equipment in low Earth orbit. Putting the best face on their decision, NASA administrators say the changes will see the agency undertake at least one major lunar landing every year from 2028 onwards. Artemis 3 will now endeavour to practice rendezvous and docking procedures with one or both commercial landers from SpaceX and Blue Origin. It'll also conduct in-space tests of the docked vehicles, integrated checkouts of life support, communications and propulsion systems, and testing the new extravehicular activity spacesuits. NASA says there's still too much to learn left on the table and too many development and production risks to proceed any quicker. The agency says the entire sequence of Artemis flights needs to represent a step-by-step build-up of capabilities, with each step bringing NASA closer to once again being able to perform a manned lunar landing. The changes also mean retaining the Space Launch System SLS rocket in its current Block 1 configuration, with its existing interim cryogenic propulsion upper stage and launch pad configuration. Originally, the plan had been for SLS vehicles from Artemis 4 onwards to use a new upgraded Block 1B launch vehicle, which would be equipped with a new enhanced exploration upper stage. There have also been concerns about the readiness of SpaceX's HLS lunar lander version of Starship, which is meant to dock with the Orion spacecraft in lunar orbit and carry two of the crew members down to the lunar surface, provide a base while they're on the ground, and then take them back to the Orion in orbit. NASA contracted SpaceX to provide HLS lunar landing shuttles for both the Artemis 3 and Artemis 4 missions. So far, Starship has flown 11 suborbital flights over the past 3 years, but it's yet to achieve some critical mission milestones needed for manned spaceflight or journeys to the Moon, which would require in-orbit refueling. As well as the Starship HLS, NASA's also slated Blue Origin's Blue Moon spacecraft to shuttle the Artemis 5 crew between the upcoming Lunar Gateway space station, which will be placed in cislunar orbit, and the lunar surface. Both Blue Moon and Starship HLS will need to demonstrate their ability to transfer and store cryogenic fuels in space, rendezvous and dock with Orion spacecraft, and undertake journeys to the lunar surface and then ascend back to lunar orbit. This is SpaceTime. Still to come, a successful hypersonic test flight for an Australian scramjet, and the hidden chemistry at the heart of the Milky Way galaxy. All that and more still to come on SpaceTime. Hypersonic's revolutionary scramjet engine has undertaken a successful test flight, powering the Australian company's Dart-A hypersonic aircraft to more than 5 times the speed of sound. The mission is seen as a major milestone in the development of advanced hypersonic systems. Scramjet stands for Supersonic Ramjet. The 3D printed engine has no moving parts. Instead, it uses its intake design alone to compress air, which is then mixed with liquid hydrogen fuel to generate the thrust needed to propel the vehicle to hypersonic speeds, even Mach 12. Just add liquid oxygen to the technology and you achieve a key step in the development of a single stage-to-orbit capability, a long-time goal for space travel. However, scramjets only begin operating when they're already travelling at supersonic speeds. Earlier tests of the engine, originally developed by the University of Queensland, were carried out at the Woomera Rocket Range in outback South Australia using sounding rockets. This latest test flight was launched aboard a modified Electron rocket called HASTE from Rocket Lab's Wallops Island Flight Facility Launchpad 2 on the Virginian mid-Atlantic coast on a suborbital flight path.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff.
Vehicle split beginning pitch over.
Stage 1 propulsion is nominal.
Well, that's not enough. That is our HASTE rocket with a textbook launch off the pad at LC2 on Wallops Island. HASTE is climbing fast now at almost 900 kilometres an hour with an almost immediate pitch over to follow today's suborbital trajectory.
Cleared max Q.
A nice clean sail through max Q by HASTE there, now at speeds of more than 2,000 kilometres an hour. Hearing good calls from mission control as well. And coming up soon will be MECO, or main engine cutoff of those engines, which is when all 9 of them power down at the same time. And now usually that is to allow for the first stage to separate from the second, but with this experimental hypersonic mission, we are doing things differently. And so, at about the same time as those engines shut down, HASTE's fairing will separate and DART will be deployed to begin its free flight at hypersonic speed.
The team will be testing the aircraft's aerodynamic control at several times the speed of sound, as well as its scramjet propulsion to power the vehicle along its suborbital trajectory.
Another hypersonic test launch with 100% mission success out of Launch Complex 2 on Wallops Island.
The mission marked the 82nd launch of a New Zealand Electron rocket and the third Electron flight this year. Hypersonics is developing a new class of autonomous hypersonic aircraft capable of sustained flight up to Mach 12. Its flagship DART-AE aircraft is a 3.5-metre autonomous hypersonic vehicle, specifically designed to validate propulsion, materials, sensors and guidance systems in real hypersonic flight conditions. During this mission, the Electron rocket carried the DART-AE to a planned deployment point in the upper atmosphere over the North Atlantic Ocean. DART-AE then executed its hypersonic mission, gathering invaluable technical data for mission managers to analyse over the coming weeks. Hypersonics co-founder Michael Smart, the former chair of hypersonic propulsion at the University of Queensland, says this mission has confirmed years of technical work. Smart says it's allowed the company to test propulsion, materials and control systems under real hypersonic speed and temperature conditions. He says the flight data will be invaluable, with results directly shaping the design of future operational hypersonic aircraft. This is SpaceTime. Still to come, the hidden chemistry at the heart of the Milky Way galaxy, and a giant gravity hole beneath Antarctica. All that and more still to come on SpaceTime. Astronomers have captured the largest image ever of the central region of our Milky Way galaxy, showing a complex network of filaments and cosmic gas in unprecedented detail. The observations are reported in 5 separate papers covered in the monthly notices of the Royal Astronomical Society. The data was obtained by the European Southern Observatory's ALMA, the Atacama Large Millimetre Submillimetre Array Radio Telescope, located on the high Atacama Desert of Chile. It marks the richest and most detailed ALMA image ever taken, and it allows astronomers to probe the lives of stars in the most extreme region of our galaxy, right next to Sagittarius A star, the supermassive black hole at the galactic centre. The observations are providing a unique view of the cold gas, that is, the raw material from which stars are formed within the so-called galactic central molecular zone. In fact, it's the first time cold gas across this entire region has been explored in such detail. The area featured in this new image spans over 650 light-years. It harbours dense clouds of gas and dust surrounding the monster central black hole Sagittarius A star. It's also the only galactic nucleus close enough to Earth for astronomers to study in such fine detail. These observations are specifically exploring cold molecular gas. That's the material needed for new star formation. The survey unpacks the intricate chemistry of the central molecular zone, detecting dozens of different molecules, from simple ones such as silicon monoxide to far more complex organic ones like methanol, acetone and ethanol. Cold molecular gas flows along filaments, feeding into clumps of matter out of which stars can eventually grow. In the outskirts of our galaxy, we know how this process happens, but within the central molecular region, the events are far more extreme. The study's lead author, Steve Longmore from John Moores University, says the central molecular zone hosts some of the most massive stars known in our galaxy, many of which live fast and die young, ending their lives as powerful supernova explosions, some even becoming hypernovae. He says the new work allows astronomers to better understand how these phenomena influence the birth of stars and whether science's theory of star formation holds true in extreme environments. By studying how stars are born in the central molecular zone, astronomers can gain a clearer picture of how galaxies grow and evolve. Christoph Federath from the Australian National University says this region shares many features with galaxies in the early universe, where stars were forming chaotic extreme environments. Federath says the work will allow astronomers to uncover how these energetic events influence the birth of stars, and whether current theories still hold in such harsh environments. A defining feature of all star-forming clouds is their highly turbulent, chaotic flows of gas and dust. Federath says near the galactic centre, this turbulence becomes extreme, weaving a dense, tangled web of filaments that ultimately collapses to form new stars. He says despite its fundamental importance, the origins of this turbulence remains one of the biggest open questions in astrophysics.
At the ANU here in the Research School of Astronomy and Astrophysics, I have a research group that works on theoretical astrophysics and in particular on star formation and also on the fundamental physics of turbulent flows. These turbulent flows are really a key process in the formation of stars. And the way this works is the turbulence, well, it does not just shake you up in an airplane or so. It also shakes up the gas in some sense to create dense regions in this material in the central molecular zone, for example, the image that we've been taking. So these turbulences, they bring gas together in some regions so that it gets so dense that gravity can take this and pull this together to form a star. And understanding these turbulent flows is really therefore a key because it's the first step in making stars. And it turns out that this turbulence can be very violent or a bit milder. It has very different properties, and those are the things that we study in my research group here at NU.
I guess the turbulence has to be at a certain level. If it's too turbulent, the molecules won't come together. Not turbulent enough, you have the same problem. The molecules won't come together.
That's right. So basically the turbulence can be very fast, say. That's one of the things it can do. And if it moves very fast but in a circle, that doesn't really help to bring material together. Yeah, it's like a carousel. If it just goes around fast and fast, none of these things really meet very fast either. But if it goes sort of from one side, comes from one side and then comes from the opposite side and moves together, so it compresses, then a very fast such compression can lead to an enormous increase in density. And that is a key difference then between what we call solenoidal or rotational turbulence, that is more like the carousel, and this compression when you like squeeze the gas. Say with a supernova explosion, you can actually create very strong shock waves, and they compress the gas and can initiate star formation in regions where two of these shocks or shock waves may collide. And that's what initiates star formation.
That also suggests that you probably couldn't make stars within a certain region of a supermassive black hole?
Yeah, that's a very good question. I mean, the material there swirls around very quickly. And so we've actually looked at this before using data set that was taken with ALMA earlier, but of a very, very localized region in the central molecular zone near the black hole, the so-called BRIC, weird name, but for molecular cloud inside the central molecular zone. So it's a very small part of the huge image that has been taken now in this bigger collaboration. But we've already learned there very locally in this region that the turbulence is more rotational, more solenoidal, to use a weird word. So it's more of this carousel type, and probably it's because of the motions and the orbits around the supermassive black hole. There's a lot of shear, and so material has a hard time coming together and being compressed, and that makes star formation less efficient than in other regions where the gas is strongly being compressed in shock waves.
That's Professor Christoph Federath from the Australian National University. And this is SpaceTime. Still to come, a giant gravity hole beneath Antarctica and a total lunar eclipse greets the month of March. All that and more still to come on SpaceTime. Scientists think they now know why the frozen continent of Antarctica sits above planet Earth's deepest gravity hole. The findings, published in the journal Scientific Reports, shows that rock density below the Antarctic gradually got weaker over millions of years. To you and I, gravity seems reliable, stable and consistent. But in truth, the strength of gravity varies across the planet's surface. And after accounting for Earth's rotation, it appears gravity is weakest beneath Antarctica. Now a new study reveals how achingly slow rock movements deep under the Earth's surface over tens of millions of years led to today's Antarctic gravity hole. The study also highlights that the timing of changes in the Antarctic gravity low overlaps with major changes in Antarctica's climate. And future research could reveal how the shift in gravity might have encouraged the growth of the frozen continent's climate-defining ice sheets. The study's lead author, Alessandro Forte from the University of Florida, says if science can better understand how the Earth's interior shapes gravity and sea levels, we can gain a better understanding and a better insight into the sort of factors that may matter for the growth and stability of large ice sheets. Caused by different densities of rock far beneath the Earth's surface, these variations in gravity are small in absolute terms, but they can have large effects on the oceans. You see, where gravity is weaker, the ocean surface sits slightly lower relative to the Earth's centre. That's because water always flows towards areas of stronger gravity. And due to its gravity hole, the sea surface height around Antarctica is measurably lower than it would otherwise be. To reach their conclusions, the authors relied on an Earth-spanning project combining global earthquake recordings with computer modelling to reconstruct the three-dimensional structure inside the Earth. Forte says it's a bit like a CT scan of the planet, but using earthquake seismic data instead of X-ray scans. This allowed the authors to develop a gravitational map of the entire planet. And the reconstructed map closely matches previous gravitational data captured by orbiting satellites. Then came the hard part, turning the clock backwards to see how Antarctica's gravity hole developed over eons. Forte and colleagues produced computer models to rewind the flow of rocks in the interior and track changes going back 70 million years, back to the time of the dinosaurs. This tracked how the current Antarctic gravity hole started off far weaker. Then, between 50 and 30 million years ago, the hole started to gain strength. The timing overlaps with major changes in Antarctica's climatic system, including the onset of widespread glaciation. Going forward, Forte hopes to test for a causal connection between the strengthening gravity hole and the ice sheets, using new modelling that links gravity, sea level, and continental elevation changes. Forte says the aim is to address one big question: how does climate connect to what's going on inside the planet? This is SpaceTime. Still to come, a total lunar eclipse greets the month of March, and later in the science report, a new study shows how human brain scans suggest there could be 3 different types of ADHD. All that and more still to come on SpaceTime. The month of March begins with a total eclipse of the moon. The celestial spectacle has provided a brilliant red moon visible across Australia, Eastern Asia, Western North America, South America, the Antarctic, and the Pacific and Great Southern Oceans. Lunar eclipses always occur 2 weeks before or after a solar eclipse. Solar eclipses can only occur during new moons, and lunar eclipses only occur during full moons. Now, normally the moon's orbital plane around the Earth causes it to pass either slightly above or below Earth's orbital plane around the Sun. But during a lunar eclipse, the Earth passes more directly between the Sun and the full moon, causing the planet's shadow to block out direct sunlight. In fact, the only light reaching the moon is first filtered through the Earth's atmosphere. Here, the light is stretched along a redder wavelength through a process called Rayleigh scattering, which acts like a lens, removing shorter bluer wavelengths. It's also tinted by dust, clouds and pollutants in Earth's atmosphere. The result is a kaleidoscope of colours, ranging from soft salmon pinks through to orange golds and deep blood reds. As we mentioned last week, it's often described, quite accurately, as all the world's sunrises and sunsets happening at once. Now, in contrast to short-lasting solar eclipses that can only be seen along a narrow line across the Earth's surface, lunar eclipses can be observed from anywhere on the nighttime side of the Earth, and they can often last for an hour or more. See, that's because the entire shadow of the Earth can cover the lunar surface during a lunar eclipse, while only a very small part of the Earth's surface is covered by the moon's shadow during a solar eclipse. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study looking at human brain scans suggests there are actually 3 different types of attention deficit hyperactivity disorder, or ADHD. The findings, reported in the Journal of the American Medical Association, show that each of the 3 subtypes have unique clinical profiles: severe, combined with emotional dysregulation, predominantly hyperactive impulsive, and predominantly inattentive. Each subtype shows different alterations across brain regions and different patterns of receptors for key brain chemicals. The authors say this offers a framework for dividing people with ADHD into clinically meaningful groups, which may ultimately create a path towards developing personalised treatments. A new study shows that watching alcohol-fueled posts on social media increases young people's desire to drink. The findings, reported in the Journal of the American Medical Association, are based on a study asking people to watch either 20 Instagram posts from influencers that showed them drinking alcohol or holding alcoholic drinks, or 20 social media posts from the same influencers but without any alcohol-related imagery. Those who viewed the booze-filled posts were more likely to report a higher desire to drink alcohol compared to the control group. The authors say this adds to growing research showing that simple exposure to alcohol-promoting content, especially on social media, is associated with alcohol-promoting attitudes and behaviours in young adults. The discovery of a tiny 1-kilogram dinosaur fossil from a group of small dinosaurs suggests that the little reptiles didn't evolve to be small all at the same time, but rather repeatedly evolved a miniature body size independently of each other. The findings, reported in the journal Nature, based on the discovery of a nearly complete fossil of an alvarezsauroid, which lived around 95 million years ago in the Patagonian region of Argentina. Paleontologists say the fossil has an estimated body mass of less than 1 kilogram, making it one of the smallest known non-avian dinosaur species from South America. It had a beak-like snout, short forelimbs, and long hind limbs with claws. Unlike previously discovered alvarezsauroids, the newly unearthed species didn't have shrunken digits on its forelimbs, and its teeth weren't miniaturized, which the authors say indicates that it evolved its diminutive body under different conditions compared to many of its relatives. A new study has found that just 1/4 of Canadians reject the idea of paranormal abilities and events. However, the study by the editors of The Conversation failed to disclose how many people were surveyed and what were the actual list of questions they were asked. And that's a bit of a worry for a science website that proudly claims on its banner to have academic rigour and journalistic fairness. The study concluded that 44.11% of Canadians believe in the paranormal. 31.33% claim to be neutral on the ID, but still believe in at least one paranormal type thing. So when you think about it, that's really another yes. And just 24.56% of Canadians didn't believe in the paranormal at all. The skeptic's Tim Mendham says the first thing they needed to sort out was a clear definition of exactly what is paranormal. For example, in Canada, psychic abilities and Bigfoot or UFOs are considered paranormal, while angels and demons are not. They're associated with religion.
They say there's a pretty firm belief that some of them, 44%, have had belief in some form of paranormality. And there's a whole range of paranormalities. You can have from psychics to coincidence to aliens, weird creatures, all sorts of different things. So 44% believe there's something in the paranormal, not necessarily every paranormal, but some. 31% are neutral and about 24% say, no, it's not true. So it's a minority of people who say it's not true. That seems to be pretty consistent with other places. One thing this survey does say is that it's actually less strong belief amongst amongst younger people than amongst older people. Another survey we looked at for Russia said the opposite. So I don't know. I'm trying to figure out exactly how many people they did ask about. They reckon it was a randomly selected survey, not sort of like everyone volunteering, yes, I believe, I want to talk about my beliefs. And they just ran through a whole range of claimed paranormal experiences and asked them, do you believe? Women are more likely to believe than men. People with bachelor's degrees or higher are less likely to believe. People aged 19 to 29 are less likely to believe than those aged 30 to 44 or 45 to 64. Some experiences that they were believing in were connected to religion, such as feeling, quote, the Christian Holy Spirit. Others are saying that they're turning away from religion and therefore not seeing so much religion-oriented paranormality. And the survey itself asks, is a religious-based event regarded as paranormal compared to a supernatural, alien, psychic sort of event? So there might be a cultural issue in there as well.
That's the Skeptic's Tim Mindham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.